Good day everyone, I'm Midshipman Aldo Mustasisa, Group 4 Leader from NS2A2. This is my members, Midshipman Mark Notario, Midshipman Cyril Palamos, Midshipman Francis Susana, and Midshipman Carlos Apues. Today we're gonna discuss or talk about the assessment way, which is the stopping distance. First of all, what is stopping distance? Is the distance which a ship will continue to move after action is taken to stop engine until the ship comes to rest. Stopping distance details may be provided for sea speed, harbor speed, hub speed, and many more. It may be provided for loaded and light condition. The first is head reach and track reach on loaded and unbalanced condition using crash stop. So what is head reach? Head reach is the total distance traveled in original direction. Then the second is track reach. Track reach is the total distance traveled along the actual path followed by the ship. An idea of distance traveled and the time taken can be achieved by the studying the following cases. So the next is the crash stop. Crash stop is usually the term used when the ship has to sudden stop in emergency situation. Here the engine which is moving in an ahead direction is given an order for full astern leaving the radar in the midship position to stop the ship with minimum distance and shortest possible time. To know the complete procedure, read the crash stop grid. Next is the head reach and track reach on ballast condition using crash stop. Head reach is the total distance traveled in original direction, and the track reach is the total distance traveled along the actual path followed by the ship. An idea of distance traveled and time taken can be achieved by the studying the following cases. Rudder cycling is the most effective way to stop the ship without changing the heading. It is uses the resistance of water on under water hood area to reduce the speed of the ship when the ship heading is returned to original course. Put the rudder on the hard to starboard to check some of the board swing. The next midshipman will be Mark Notario.
Good day to all of you. My name is Midshipman Mark Andrew Pinotario from NS2A2, and today I will explain the head reach and track reach on loaded condition using rudder cycling method of stopping the ship. So the rudder cycling. Moving the rudder between hard to board and hard to starboard is it increased drag. The technique relies on moving the rudder without inducing a turn. When you move a rudder, it does take some time for a vessel to begin turning, so you can keep it harder over a little while. As the turn begins, though, you turn the rudder hard the other way. These relatively rapid rudder movements lead to the term of high-frequency rudder cycling, and it slows the ship using only the additional drag created by the rudder itself. Developing the idea further, we move on to low-frequency rudder cycling. The idea is you do induce a turn, you want the vessel's drift angle to increase your drag. You will get a vessel swinging 30 or 40 degrees one way before returning to your original heading, reducing the engine power the whole time as the vessel's momentum is in this direction. The increase in angle leads to a huge increase in drag rapidly, slowing the ship. Low frequency rudder cycling can get a ship stopped within 5 or 6 ships length. So on a 300-meter ship, you would stop within a mile or so, of course, if there are no restriction with regards to zero. That's all. Thank you for listening.
Good day, I am Midshipman Sir Ray R. Palamos from NS2A2. Today I am going to discuss the head reach and track reach on ballast condition using rudder cycling method of stopping the ship. The analysis of track reach and head reach accurately conforms the mathematical model of a ship in ballast condition. To perform this, the vessel is at full speed ahead on a specific course that should be noted before you begin. Put the rudder hard to port and reduce speed to half ahead. Then shift the rudder to starboard and reduce speed to slow ahead as the ship passes the original course. Put the rudder hard to port again and reduce speed to slow. When the ship returns to the original course, turn the rudder hard to starboard and turn the engine astern to slow down or eliminate all headway.
Is the fifth topic for assessment 3, the inertia stop method. Headway of a ship going ahead is reduced to a ship merely by cutting off the fuel without reversing the propulsion. Stopping distance may be associated with the speed at which the vessel was advancing at the time of the stop, speed in knots represented in nautical miles. When the engine of the ship is stopped, the ship will continue moving in the same direction for some more distance due to inertia. Here no astern command is given, used to produce braking effect to the ship, and hence ship will travel more distance in the inertia stop method.
Good morning, ma'am. Good morning, classmate. I am ordinary A. Zapres. Stopping distance of ship. As well, all know ship, like any other transport utility, does not have brakes to make them stop immediately. When the engine is giving stop order, the ship will continue moving in the same direction due to inertia and will come to stop after moving for some distance. Inertia stop, as described above, when the engine of the ship is stopped, the ship will continue moving in the same direction for some more distance due to inertia. Here no astern command is given, and hence ship will travel more distance in the inertia stop method.